Okay, we're almost halfway. Number 21. I noticed the numbers got screwed up too, so I have to change them. That's why those big blobs are on the left. Anyway, number 21 is find the slope of the line that passes through the given points. 4, -5, and 10, 7. We've got our slope formula. So we just plug in our values. But before we do that, okay, so we're going to plug our x and y coordinates into this equation for slope. But it's wise to pick a first point and a second point. Doesn't matter which one you decide is first, as long as this one's first already. It's in front of the other one. I'll make that one x1, y1, this x2, y2. So now it's a little bit easier to plug in these values. Notice y2 minus y1. Since the y1 is negative, I always do this in parentheses so I don't lose one of my signs. And that's over x2, which is 10, minus x1, which is 4. Don't need a parentheses there. Okay, 7 minus a -5 is the same as 7 plus a positive 5, so that's 12. 10 minus 4 is 6. 12 divided by 6 is 2. So, slope is 2. M equals 2. Number 22 is find the slope of the following line. Now, we could find 2 points first, right? We could put in 0 for x and get y as a -4, and we could put in 0 for y, and then x would be a +4. And we could use that to find our slope using the slope equation, which we already talked about up here. But the best way to do this is just to put it in the slope-intercept form. So we've got a -x plus y equals a -4. Alright, so let's add x to both sides. And we get y equals x minus 4. So the slope is right here, which would be 1. It's understood. So m equals 1. Number 23, find the equation of the line given in the graph. So now remember our slope-intercept form. Y equals mx plus b. M is our slope, b is our y-intercept. So let's find the y-intercept. Here it is. It's a -5 on the y. So -5. Okay, so now we've got to find another point that we're sure of. And another point we can be sure of is this one right here. So we've got our second point. So we'll count up from our point that we have. Our y-intercept. Let's see how many we go. We go up 1, 2, 3, 4, 5. So maybe 5 over 1, 2. 5 over 2. And there's our equation. 5 over 2 is our slope. So it's 5 over 2x plus a -5. Good job. Again, we'll use our slope-intercept form here. It says solve for y and graph by using the slope and the y-intercept. So we're going to find them by solving for y. Okay, so it's x plus 4y equals okay, solve for y and graph by using the slope and y-intercept. So we're going to get this in terms of y. Let's add a negative x to both sides. X, negative x, whoops, plus 4y equals negative 8 minus x. So the x's cancel out. These x's cancel out. And we get 4y equals a negative 8 minus x. We want to put our x term first. So let's make it 4y equals negative x minus 8. And to get our y, just y, divide by 4. So we have y equals, and now this 4, just like when we do distribution, that 4 has got to divide into both that and that, both into the negative x and into the negative 8. So let's do it. We get a negative x over 4 and a negative 8 over 4. Okay, so negative x over 4 is the same as a negative 1/4 x, and negative 8 over 4 is the same as a negative 2. So here we have our slope equals a negative 1/4, and our y-intercept equals a negative 2. So let's start with the y-intercept, negative 2, right there, or thereabouts. And let's count our slope. It's so down 1 and over 4, down 1 over 1, 2, 3, 4, right there. And so now we can graph it. Use a ruler. Let me try that again. And I'm sure you could draw a better line than that, but that's the best I can do on this touch screen. Number 26, determine whether the lines are parallel, perpendicular, or neither. Well, first, I'll give you a quick tutorial on what makes a parallel line or a perpendicular line. If you have your coordinate plane and you have parallel lines, all the parallel lines are like this, right? Well, notice that the parallel lines, well, that wasn't so good, but parallel lines have all the same slope. They're inclined the same amount. So parallel lines have the same slope. Okay, but what about perpendicular lines? What about them? Lines that are perpendicular to each other, you're going to notice a few things about them. One is if this, let's say we'll call it A, and then we'll call this one B. Notice that line A and line B have different signs for slopes. Line A's slope is positive, line B's slope is a negative slope. Okay, so line A and line B are perpendicular to each other. So anytime except for like a vertical slope, which is undefined, all slopes are going to be the opposite of each other. If a slope is, or if a zero slope and an undefined slope, well, they're different story. But every other line, they're going to be the opposite signs. So that's one thing. Whatever your perpendicular slope is, if one is positive, the other is going to be negative. Or if one is negative, the other is going to be positive. And the other thing is they're opposites. You notice they're the opposite slope. One's going uphill at the same angle, the other one's going downhill. Right? So they have inverse slopes. The inverse slope would be the reciprocal. The reciprocal is basically making your number a fraction and turning it over. So in this case, we have one has a slope of 4, and the other has a slope of a positive 1/4. So they're not parallel because they're not the same slope, and they're not perpendicular because negative 1/4 is not the opposite sign. They're both positive slopes, so they can't be perpendicular. A slope that would be perpendicular to 4 would be a negative 1/4. Alright, so, and a slope perpendicular to 1/4 would be a negative 4. So, the lines are not parallel and they are not perpendicular. They are neither. Number 27. Find an equation of the line with the given slope that passes through the given point. Write the equation in slope-intercept form. Okay. Slope is a negative 2. A point is 4, negative 3. Well, slope-intercept form, y equals mx plus b. We've got our slope, so we'll stick that in. So we have y equals a negative 2x plus b. Okay, so obviously we're missing our b. What we do have is this point. And that point is just one of the points on the line. And if it's in this equation, and it says it goes through that, so it's in the equation. It's on the line, it's in the equation. So we just can stick those coordinates in. We'll stick in the 4 for x and the negative 3 for y. So we have, let me do it over here, negative 3 equals, see the negative 3 is in for y, equals, negative 2 times our x, which is 4, plus b, which we still don't know. But now you notice we have an equation with only one variable, so we can figure out what b is. Simplifying, negative 3 equals negative 2 times 4 is negative 8 plus b. Of course, we want to get our b alone, so we'll have to add 8 to both sides. 8 to this side, plus 8 over here. And so the 8's on this side cancel out, and we get b equals, and positive 8 plus a negative 3 is a positive 5. So our b is 5. So the equation of our line then, in the y equals mx plus b form, is y equals negative 2x plus 5. Number 28. A taxi charges a base fee of $3 plus $1.20 per mile. Write an equation that models the described quantity. Use C to represent the total cost and M to represent the number of miles. Now, if you remember, when we graph these things, that the slope, the M, is the change in rate. Slope is the change in rate. So we have to look and see what is our change in rate. Our change in rate is $1.20 per mile. So that's our slope, $1.20. Now the $3, that's extra, right? That's its base fee, so it's charged. You have to pay that no matter how far you drive. So it makes sense that if we were going to put it into y equals mx plus b form, the change in rate, that's going to be our m. So we have y equals, let's say, 1.2 times x plus our b. The thing that doesn't change is there from the beginning, and you always get charged it, right? So it's plus 3. There's our formula. Y equals 1.2x plus 3. Alright, really this is 28. Somehow the numbers got off. Anyway, we have to just keep plugging no matter what, right? So number 28, decide whether or not the ordered pair satisfies the system of linear equations. Uh-oh, what happened to the ordered pair? Alright, actually there's the ordered pair right here. And here's our system of linear equations. Okay, so to see if that ordered pair satisfies the system of linear equations, we have to stick the ordered pair into both equations and see if it comes out with one side equaling the other. So let's start with the top one, 3x plus 5y equals 6. 3 times our x is 2. We just plug it in. Plus 5 times the y, which is 0, equals 6. Okay, 3 times 2 is 6. 5 times 0 is 0. So 6 equals 6. Okay, good. Satisfies that one. Now let's try the other one. 2 times our x is 2. 2 times 2 plus 7 times 0, again, equals 3. Let's see if that's true. 2 times 2 equals 4. 7 times 0 equals 0. So does 4 equal 3? No. 4 doesn't equal 3. So it doesn't satisfy. It doesn't satisfy this one. So it doesn't satisfy. Big NO.